In this video, we'll be going through price elasticity of demand. And this is in conjunction with understanding how demand works and the reasons for the changes in demand in accordance with changes in price. So if we get cracking, first we can define what price elasticity of demand, or PED as we know it. Basically what it is PED, price elasticity of demand, measures the responsiveness of demand as a result of a change in price. So we want to measure how much the demand of a good changes when there is a relative change in price. So the percentage change in quantity demanded given a percentage change in price. Now we know when the price goes up, demand goes down. In opposition to that, when price goes down, we know that price goes up. Alright, so there is an inverse relationship between price and quantity demanded. That's not the question here. What we're trying to understand here is by how much does demand go up and down and increase with that change in price. So if the price goes up by 10%, by what percentage does demand go down by? The best way to do this is to go through an example. If the price of petrol reduced from £1 per litre down to 0.5 pounds per litre, so 50p per litre, demand would then increase, and we can see this on the diagram where we've gone from 10 million to 12 million as a result of the price decrease from £1 down to 50p. So it's very important to understand that we've seen a massive price reduction resulting in a relatively smaller quantity increase in terms of percentages. And if you notice the steepness of the curve and the actual changes in demand, we can start to understand what we're talking about here. The price, as can be seen, we've reduced by 50%. How did we work that out? We did the new price minus the old price divided by the old price multiplied by 100. So 50p minus £1 divided by £1 multiplied by 100, and we got 50%. Okay, that's how we worked out the 50% change in the price reduction. Now, what else do we want to do here? We want to work out the percentage change in the quantity demanded. How do we do that? New minus old divided by old multiplied by 100. And then that obviously equals 10 to the 12 million, 10 minus 12 divided by 10 multiplied by 100. And we got 20%. From 10 to 12, that's a 20% increase. Okay then, why do we need to know that? And it's basically, we want to put it into a formula in order to calculate price elasticity of demand. And that formula is here. Percentage change in quantity demanded divided by percentage change in price. How much has quantity demanded changed in relation to that change in price? And this equals the price elasticity of demand. Please do not forget this, because you'll be using it, whether it's in micro and maybe even in macro as well when you're talking about other subject areas. So it's quite crucial that we do so. So, percentage change in quantity demanded. We've already worked that out, haven't we? And what did we get? We got 20%. Okay, so in the numerator we put plus 20%. Because quantity demanded has gone up by 20%. On the denominator, what's happened to price? Price has fallen by 50%. And if we then calculate what this is going to result in, this is going to lead to a calculation whereby the PED equal 0.4 minus 0.4. So price elasticity of demand is inelastic where 0.4 is less than 1. We're going to go through these in a second. So what does that mean? And that basically suggests that the price elasticity of demand here for petrol is inelastic. So basically, if you were to reduce the price of petrol, there will be a less than equivalent increase in the quantity demanded. Now, that's suggesting that it's not beneficial for the companies, the petrol companies or the oil companies, to reduce their price for petrol. Why? Basically, it's going to reduce their revenues. So let's have a look. What does revenue mean? Revenue is all to do with price times quantity. So at what price do you sell and for what quantity? So if we were to calculate price times quantity for each one, it's going to show us that price has actually fallen by more than the quantity demanded has risen. So therefore, if we were to take into account the old section here between £1 and 10 million, this rectangle is much bigger than the rectangle of the new price and quantity. And that's basically suggesting that how much revenue have we lost? And if we were to draw it here, this is showing that we've lost all of this revenue we've lost this revenue, but instead we've gained this much. And that's how you can see that you've actually lost revenue, because the blue reduction in revenue is far greater than the gain in the green one. And therefore that's resulted in a decline in the revenue if you were to reduce the price of a good that's price inelastic. And the reason being is because there's very few substitutes to petrol. So even though it's really cheap, it's much cheaper now. You're not going to sit there and increase your demand of it, because you're just using it as you would do normally. So essentially, you want to, what you're doing is you're still continuing to to consume petrol the way you were initially. What's going to happen is you're going to get a few increases in demand, in revenue, and you're going to have reduced revenues as well at the same time. But which one is far greater? And it's the one with the reduced revenue. There are other products like petrol. It's a normal good, and therefore it's an essential item. There are very few substitutes. Even if the price falls as dramatic as that 50%, it's not going to drastically increase the demand for it, given households and businesses already use the petrol for transport, energy, production on a daily basis. So therefore, it's only going to go up by 20% and not the 50% or more that we would think it would. So hence it results in a reduction in revenue. And that's the essential part. That's where the detailed analysis comes in.